Welcome back to e-chemistry class. Continuing further with class 10, chapter 1, chemical reactions and equation. Let us go through the text as well related to the topics we have already covered. Chapter 1, chemical reaction and equations. Consider the following situation of daily life and think what happens when milk is left at room temperature during summer. An iron tawa, pan or nail is left exposed to humid atmosphere. Grapes get fermented. Food is cooked. Food gets digested in our body. We respire. Now we already saw that these kind of changes are called as chemical changes. Why are they called chemical changes? Because during this change, a new substance is formed. So, in all the above situations, the nature and identity of the initial substance have somewhat changed. We have already learnt about physical and chemical change of matter in our previous classes. Whenever a chemical change occurs, we can say that a chemical reaction has taken place. So, what are we going to study in this chapter is chemical reaction, which occurs only when a chemical change occurs. So, there is a close relation between chemical change and chemical reaction. You may perhaps be wondering as to what is actually meant by chemical reaction. How do we come to know that a chemical reaction has taken place? Let us perform some activity to find the answer to this question. This activity needs the teacher's assistance. It should be better if the students wear eye protection. Clean a magnesium ribbon about 2 cm long by rubbing it with sandpaper. So, we are taking a substance called magnesium. We are familiar with the elements present in the periodic table, and the symbol for magnesium is Mg. We are rubbing it with sandpaper. Hold it with a pair of tongs, burn it using a spirit lamp or burner, and collect the ash so formed in a watch glass as shown in the figure. Burn the magnesium ribbon, keeping it as far as possible from your eyes. What do you observe? We must have observed that magnesium ribbon burns with a dazzling flame and a change into a white powder. This powder is magnesium oxide. It is formed due to the reaction between magnesium and oxygen. So we can say a chemical reaction has occurred. Here we'll study further in the chapter that how the chemical reactions are represented symbolically. These are word equations which are just describing an event which is a chemical change. Let us see one more example in activity 1.2. Take lead nitrate solution in a test tube, add potassium iodide solution in it. What do you observe? We observe that yellow precipitates of lead iodide is formed. This also shows a chemical change has occurred and a chemical reaction has occurred. Let us take an example of zinc granules. Take a few zinc granules in a conical flask or a test tube. Add dilute hydrochloric acid or sulfuric acid to this. Handle the acid with care. Do you observe anything happening around the zinc granules? Touch the conical flask or test tube Is there any change in the temperature? From the above three activities, we can say that any of the following observation helps us to determine whether the chemical change has taken place. Change in state, change in color, evolution of gas, and change in temperature. So, in the first example, we saw that a white solid powder is formed, that is, change in color and change in state to some extent. In second example, there is change in state and change in color, and in third, evolution of gas and change in temperature. So, as we observe the change around us, we see that there is a large variety of chemical reactions taking place around us. We will study about the various types of chemical reactions and their symbolic representation in this chapter. So, are you all clear with the concept of a chemical change and a physical change? And what is a chemical reaction? Chemical reaction is the phenomena which occurs due to the change in the chemical properties of any substance by breaking or making of new bonds. Now let us see what are chemical equations and the difference between chemical reaction and chemical equation. Activity 1.1 can be described as when a magnesium ribbon is burnt in oxygen, it gets converted to magnesium oxide. This description of chemical reaction is a sentence form is quite long. It can be written in short form. The simplest way to do this is to write it in form of word equation. Magnesium plus oxygen gives magnesium oxide. Here magnesium and oxygen are called reactants and magnesium oxide is called product. The substance that undergoes chemical change in the reaction, that is magnesium and oxygen, are called the reactants. The new substance that is formed, for example magnesium oxide here, formed during the reaction is the product. A word equation shows change of reactant to product through an arrow placed between them. The reactants are written on the left side LHS with a plus symbol between them. Similarly, products are written on the right side with RHS with a plus symbol between them. The arrowhead points towards the product and shows the direction of the reaction, which we have already studied in the previous video. Now, how to write a chemical equation? Is there any other short way for representing chemical equations? Chemical equation can be written more concise and useful if we use chemical formulas instead of words. A chemical equation represents a chemical reaction. If we recall formula for magnesium, Mg, oxygen O2 and magnesium oxide, it is MgO. The above equation can be written as Mg plus O2 gives MgO. Count and compare the number of atoms on each element on the left hand side and right hand side of the arrow. Is the number of atoms of either elements the same on both the sides? If not, the equation is an unbalanced equation because the mass is not the same on both the sides of the equation. Such a chemical equation is a skeletal chemical equation for the reaction. Chemical equation 1.2 is a skeletal chemical equation for burning of magnesium ribbon. So, if we count here, the number of atoms of Mg is 1, O is 2, Mg 1 and O 1. So there is an extra oxygen atom on the left hand side, and so it is called as an unbalanced equation. Now we are going to study about balancing the chemical equation. To balance this chemical equation, recall the law of conservation of masses that you studied in class 9th. Mass can neither be created nor be destroyed in a chemical reaction. That is, the total mass of the element present in the product of a chemical reaction has to be equal to the total mass of the elements present in the reactant. In other words, the number of atoms of each element remains the same before and after the chemical reaction. Hence, we need to balance a skeletal chemical equation. Is the chemical equation balanced? Let us learn about balancing a chemical equation step by step. For example, the word equation for activity 1.3 may be represented as Zn, that is zinc plus sulfuric acid gives zinc sulfate plus hydrogen. The above word equation can be represented by following equation, that is Zn plus H2SO4 gives ZnSO4 plus H2. Now if we tabulate the elements and the atoms of these elements, then we have elements are zinc, hydrogen, sulfur and oxygen. Number of atoms of the reactant zinc is 1, hydrogen is 2, sulfur is 1, oxygen is 4. And number of atoms in the product zinc is 1, hydrogen is 2, sulfur is 1 and oxygen is 4. So we can see that the number of atoms of all the elements participating in the equation is same on both the sides, and therefore it is a balanced chemical equation. As the number of atoms on each element is same on both the sides of the arrow, it is a balanced chemical equation. Now let us try to balance the following equation. Fe plus H2O gives Fe3O4 plus H2. Step 1. To balance the chemical equation, first draw boxes around each formula. Do not change anything inside the box while balancing the equation. Fe plus H2O gives Fe3O4 plus H2. Step 2. List the number of atoms of different elements present in the unbalanced equation. Here we have Fe 1 and in product 3, H 2 in reactant and product 2, oxygen 1 in reactant and product 4. It is often convenient to start balancing with the compound that contains the maximum number of atoms. So here the maximum number of atom is 4. It may be reactant or a product. In that compound, select the element which has the maximum number of atoms. Using this criteria, we select Fe3O4 and the element oxygen in it. Yes. So there are 4 oxygen atoms on the RHS and only 1 on LHS. To balance it, we multiply 4 on the reactant side and we get 4 atoms on the reactant side as well. To equalize the number of atoms, it must be remembered that we cannot alter the formula of the compound or element involved in the reaction. For example, to balance the oxygen atom, we cannot put coefficient 4 as 4H2O and not H2O4 or H2O bracket 4. Now the partially balanced equation will become Fe plus 4H2O gives Fe3O4 plus H2. Now Fe and H atoms are still not balanced. Pick any of these elements to proceed further. Let us balance hydrogen atom in partially balanced equation. To equalize the number of hydrogen atom, make the number of molecules of hydrogen as 4 on the right hand side. So by multiplying 4 on right hand side, we get Fe plus 4H2O plus Fe3O4 plus 4H2. This equation is still partially balanced. We need to further check the elements, any which is not still in same number. Examine the above equation and pick up the third element which is not balanced. You find that only one element is left to be balanced, that is iron. The initial 1 in Fe and 3 in Fe3O4. To balance, we multiply by 3 on the reactant side, so equal Fe to take 3 atoms of Fe on the LHS. The 3Fe plus 4H2O gives Fe3O4 plus 4H2. This is the final balanced equation. The number of atoms of the elements on both the sides of the equation are equal. This equation is now balanced. This method of balancing chemical equation is called hit and trial method. As we make trials to balance the equation by using the smallest whole number as coefficient. Now writing symbols of the physical state. Carefully examine the above equation. Does this equation tell us anything about the physical state of each reactant and product? No information has been given in this equation about this physical state. To make a chemical equation more informative, the physical state of the reactant and product are mentioned along with their chemical formula. The gas, liquid, aqueous and solid state of reactant and product are represented by notation into bracket G, into bracket L, into bracket AQ and into bracket S respectively. The word aqueous bracket EQ is written if the reactant or product is present as a solution in water. The balance equation 1.9 becomes 3Fe solid plus 4H2O gas plus Fe3O4 solid plus 4H2 gas. Note that the symbol G is used with H2O to indicate that in this reaction, water is used in the form of steam. Usually, physical states are not included in chemical equations unless it is necessary to specify them. Sometimes the reaction conditions such as temperature, pressure, catalyst, etc. for the reactants are indicated above and or below the arrow in the equation. For example, CO gas plus 2H2 gas at 340 atm, that is atmospheric pressure, gives CH3OH liquid, that is ethanol. Here carbon monoxide reacts with hydrogen gas at 340 atmospheric pressure to give methanol. 6CO2 aqueous plus 6H2O liquid in presence of sunlight and chlorophyll gives glucose C6H12O6 aqueous plus 6O2. Using these steps, we can balance equation 1.2 given in the text. So, will you be able to answer the questions given here now? Yes. So, for now, we end this video here and see you soon with the next part of the chapter.